Hey everyone, in today's video, we're going to find out if my $450 gamble on this Marantz 2245 was worth it or not. I got this on eBay, obviously, by the tape, and it was listed as for parts of repair for a few good reasons. I saw a few things in the pictures and I thought to myself, I think I'm willing to take this gamble. Let's see what kind of condition this thing is in and let's see if we can get it back to life. Heavy, 35 plus pounds. That sticker is placed on all sides of this box. And it says sensitive electronics, but I think on this channel we've proven these are not so sensitive. Let's see if we have to do that again. Believe it or not, folks, I've worked on maybe 4 Marantz 2270s and I think 3 2230s. This is my very first 2245. Let's see what we've gotten ourselves into. Check this thing out. It is dirty. The faceplate is very dirty. And here's the main problem right here. Or at least what appears to be on the surface the main problem. There's a broken power switch. Let's see if the gyro touch still works. Yes, it does. But this looks well loved, well used. That feels okay. Everything, ooh, that's a tough to turn balance knob. And this volume knob is even tougher to turn. Wow, seriously, this is about as fast as I can turn it. Like I really need to pinch hard to turn that thing. It's smooth, but geez, that's unusual. But I mean, it looks like most of this stuff will buff out of the faceplate. I think the faceplate might be okay after a cleaning with the polish. The case, better than I thought. There's really not too much going on with this case. Up top, very nice. You got that right there, you know, whatever. And then back here, this is where I noticed something very important. The seller said that they cannot get this receiver to turn on. The power switch is broken and you plug it in and it won't turn on. But maybe some of you have already noticed. Look right here. I think we know now why this won't turn on. We have no fuse. And of course we got, you know, broken AM antenna. Very common, whatever. I could probably 3D print a new piece and just be done with it instead of buying a new one that's just gonna break the same way on eBay. Another notable thing, speaker connectors, none of them are cracked, even though the unswitched outlet is cracked. We've got our main in pre-out jumpers, which is actually a really big deal. And then over here, still looking pretty good. So really the big gamble here is what the heck is going to happen when I put a fuse in here and try turning this thing on? Is it going to work? Is it going to make sound? Or is it going to go up in flames? We don't know, but there's only one way to find out. Let's get this inside and do it. All right, it is time to get started on this thing. It's been a few weeks since I bought it, but here we are. We're going to find out if this thing works today. You know, I suppose the first thing we have to do is turn this around because there is no fuse holder, and we'll need to source one of those. Let's see if the trusty old 2215B can lend us a hand here. So take this one out. And it is a good fuse. And does it go in here? Sure does. That was pretty easy. Now I was seriously thinking about not putting this on the dim bulb just for the fanfare, but I think I'll just put it on the dim bulb because that really is the right thing to do here. You know, it was fun doing that with the carver and all that, but many of you were very offended by that. All right, let's take bets. I am willing to bet that this receiver mostly functions. It just has the broken power button and the fuse was taken out because that's what the previous owner was doing as a switch. And they lost it once it came to the eBay seller. So let's see if I'm right about that. Let's see if we get a bright bulb here. Moment of truth. Oh no! Oh no! Now we have to actually do something. Oh no! What are we gonna do about that? All right, let's pull the cover. Let's pull it mend it Mark style. Videography wise, of course. I don't have one of those fancy electronic screwdrivers. Okay, I've turned on the overhead light so we can all see at the same time. Nothing crazy, just a regular amount of dirty. Not terrible. I've seen far worse, of course. Okay, right off the bat, I noticed a few things. Number one, we're not the first person here. The factory would never leave that track like this. They also didn't grease it like that. And funny enough, that grease is seen other places, particularly on these mica insulators and the output transistors. Second thing is I don't recognize those output transistors. Those might be replacements. All of the 2230s and 2270s I've worked on, they have output transistors that literally say Marantz on them. So I guess we can start out here in easy mode per se. Oftentimes when you've got a bright bulb on the dim bulb tester, it means you've got a blown output transistor or a shorted output transistor, basically creating a direct connection between the DC rails and ground. So let's just pull these two and see what we've got going on. So, well, that right there is a red flag to me. It normally doesn't come out that easily. Normally it gives some level of resistance. This one's a little tougher to get because of the chassis being in the way. Nothing we can't overcome though. Alright, I can fish those guys out real quick. There we go. You can check these easily with a multimeter, but it's just as easy to do this, if not easier. So let's hook up the 3 pins. What do we got? Okay, that one's fine. Nothing wrong with it. Now let's check this one. This one's also fine. Let's move on to the left channel and see what's going on over here. Let's try this again. That one's okay. And one more time. Power amp transistors are fine. What could it be, folks? What could it be? We're gonna have to look underneath next. Those screws are all very corroded and rusty. Kind of gross. Alright, the reason we're under here is because I want to check the filter capacitors. I think there's a bridge rectifier somewhere. At least there is on the 2270. It would appear that I am the first person here, I think. So that's kind of cool. Let's go over here and check the filter capacitors. I don't expect there to be anything wrong here. In circuit / short. I mean, that makes sense. You know, it is in circuit, but I don't normally get that from a filter capacitor. So that one's working. I will bet you that there might be something wrong with our positive rail here. I will bet you. And I found the bridge rectifier. It is that thing clamped onto the chassis right there. So I will go ahead and check that for shorts. So those 2 orange wires are going to be your secondaries coming off of your power transformer. And if I measure the resistance across those, I get 0.6, which is good. If it were 0, we'd be in trouble. You do want some small amount of resistance across a transformer secondary. So that's a good thing right there. So now what I think I'll do is I'm going to desolder these from the bridge rectifier and get a more fair diode test that way. So essentially what I've disconnected is our connections to our positive filter capacitor and our negative filter capacitor. Negative is the white wire, red is the positive wire. So remember, we got a weird reading out of our positive filter capacitor. So let's check here right now, the negative one. This should be a diode, and we have a diode that way, and we don't have one that way. So what we should have over here is the same thing. And we don't. Found it! shorted bridge rectifier on the positive rail. Now I'm curious, do we have an actual reading out of our positive filter capacitor now? Let's see. Yes, we do. So there you go. Let's get that replaced. I diode R 5B2 5E. Positive rail, negative rail. I'm going to do some research on this. Do I replace it with a like component if they exist, or do I do some point-to-point sloppy BS and make my own bridge rectifier and go about it that way? These are questions. I'll report back when I know more. So I've drawn you all a lovely little picture of more or less what's going on in this receiver. The service manual is kind of tough to read, kind of tough to understand, so I'll just kind of walk you through this. This is our bridge rectifier, this little diamond of diodes here. We've got our two AC lines coming off of our transformer, and then they're going to go into here and here of the bridge rectifier. So what's going to happen is that the common cathode, you're going to get your positive rail, and at the common anode, you're going to get your negative rail. And then these guys right here are the big filter capacitors. We saw that we had a short right here, so we were getting weird stuff out of there, because stuff was probably making its way back to ground or something. I don't know. But then we've got these two guys right here, and these are those two cylinder hot dog looking capacitors that were on there, and they just go straight to ground. They're basically a snubber for the AC to go to ground. Now that is not something I normally see on a receiver or a power supply like this. Like if you look at Pioneers, you don't see that, and anything with just like your standard discrete diode bridge rectifier doesn't normally have that. I also did research on how do you replace this thing in my dotted line here. This is my bridge rectifier module, my 5B2, and there is a seller on eBay that has a printed circuit board that you can populate with components that they sell you, so you can in effect make your own modern version of a 5B2, and then once you assemble that, you can just mount it exactly where the old one is. See, I've still got my old one in there. But what I decided to do is, since I don't feel like waiting for that to show up, by the way, it's only 10 bucks plus $6 shipping and handling, which is a steal if you ask me, because you're about to see all the BS I go through putting this thing together. I'm going to make my own bridge rectifier, and I'm going to put these 0.01 microfarad capacitors across each diode, and that is basically how Pioneer does it. If you're looking at this and you're thinking, that's for point-to-point stuff, that doesn't go in here. Well, does it not match? It's right there. And it actually mounts perfectly. It fits right in here with the original mounting point for this ground. It sits right in there. So once I get this thing thrown together, we'll pop that in there, solder our wires, and see if it works. There it is. Not pretty, but I'm pretty sure it'll be functional. The idea is we put our two AC lines in the middle and our positive and negative on the outsides. So let's go throw that in the receiver. So what I'd like to do now is I'd like to give this thing a test with the variac and the dim bulb. And what that's going to do is it's going to allow me to vary the voltage, so I only put a little bit in here. I just want to make sure what's happening is supposed to be happening, and then the dim bulb will be just further circuit protection. So without further ado, I'm going to turn that on. I'm going to turn this on. And I'm going to bring this up to just a few volts, like 30 volts. And that should be enough for me to look at the transformer secondary, which is this. And we see we have something there. So now what we want to do is we want to measure from ground to our filter capacitors and see what we've got going there. So I'll just pick ground right here. And then I see on my positive filter capacitor, well, I'm going to switch to DC. On my positive filter capacitor, I have 9 volts, and on my negative, I have negative 9 volts, which is exactly what I want to see. We did not have that before. Now what we can do is we can take this off the transformer, plug it right back into the wall on the dim bulb. Let's see if we get a bright light, relay click. What? Oh, would you look at that, folks? Wait for it. Wait for it. Ha ha ha. Relay click. This receiver probably works. I'm glad this thing ended up in my hands. This was listed as $600 or best offer on eBay, and I lowballed the heck out of them. I think I went down to 200 maybe, because that's just what I do on eBay. I like to lowball people really hard and just see what happens. And to my surprise, they came back with $375. And in today's market, that's not horrible. Some might actually say that's good. And maybe there's a reason why they were willing to go down so low. Maybe they knew about this, but honestly, I think that's some gross speculation. They probably had no idea. They probably just picked this up from somebody. And, well, here we are. I guess we can keep it on the dim bulb and just see what happens. Let me turn off this light. Here's what we've got for lamps on our display. So we're going to need all new fuse lamps. Let's check our indicators. We've got FM. Do we get FM stereo at all? Not yet, no antenna. Our stereo lamp does not work. So we'll need to replace the stereo lamp. Tape light works and aux light works. So all the indicators work except for the stereo light, which is very sad. We love the stereo light. So anyways, we're going to go to FM. It appears we are tuned to a station. Turn our speakers on. Oh dear. Well, that's not going back out. And that one's not either. Oh, this might be a disaster. No, that's effed up. That's going to need some major cleaner. We're going to be in for a wild ride with this thing, I think. Before we do any further testing, we're going to have to reinstall our output transistors. And before we do that, we're going to have to check to make sure our filter capacitors are drained, because we don't want to be messing around with that if there's a problem. 0.5 volts is fine. And 0.6 volts is fine. We're good. Okay, I think that's in. Throw this back on. Now let's take a look at these speaker terminals. I believe our mains are turned on. Let's see what we get here. About 35 millivolts and 37 millivolts. Similar, that's good. Now let's turn the volume up. We're in FM. We should have some kind of AC coming out of here, maybe. And we do. That looks like music to me. Oh, well, it went away. What's going on here? What about the right channel? There's something. Interesting. But it would appear to me that with this lowish DC offset, you should be good to connect some speakers and take a listen. I hear music. What about this one? Yes, it works. So, right channel is quiet, left channel is not. Okay, I hear it very quietly. Let's see if this changes anything. That does adjust the volume. Is it a switch? Very well could be a switch, for all I know. They're not working. Turn our... Is it a selector switch? Tape monitor? Mono? Low filter? High filter? Loudness, I don't know. But it definitely sounds like preamp because that's pretty quiet. I forgot about the relay. Let's try poking the relay. Maybe not the relay. That's okay. Let's plug into aux over here and try everyone's favorite song, see if it's an FM specific problem. And we'll go ahead and play it. Make sure volume's up, and it is. Interesting. Let's test our remote speaker and see if that does any better. It does not. And I'll throw that left speaker into the mix. We can see our left speaker works just fine. So, there's something wrong with the right channel. And even though these controls are exceptionally dirty, it's not clear what exactly is causing the problem. I mean, this very well could be a faulty volume control with how bad that's turning. So, go back to the right channel. My God, that's bad. So I think the best course of action here to figure out what's going on with this right channel is to get out the scope and play follow the signal. So we're going to have the sine wave coming into this thing. We're going to compare right and left channels until we see a discrepancy. So let's go do that. So for this, I will remain on the dim bulb. Let's go back over to aux. And there's our sine wave going through. So I'll turn off the speakers for this because I don't want to listen to that. Pull through that switch. Alright, so we got our probe here. We gotta set it to, just this one. See, you can see me touching it. We make things happen there. I know that my signal comes in right here at the aux cable. So let's make sure we've got it coming in. So there's our sine wave. We can see it right there. It's coming in the right channel. And then if we look at the left channel, it's also coming in the left channel. Great. So it's making its way in. So now I'm going to look at the exit point because it's really easy to look at that with the relay here. So I know that my sound is going to come out of these points right here. So I've got something right there. Can I control it with the volume control? Yes, I can. And then what's going on at the other side? Not much. Can I control it with the volume control? Yes. It is far reduced. Ooh, that's not right. We don't like that very much. So we got to find out why it doesn't look like that and why it looks like that instead. Where does that happen? So if we go over to our volume knob over here, we can see what's coming off of the preamplifier. And I can look at one side, this yellow wire, and then I can look at the other side, and they look to be the same. So let's go to the other end of our volume control. So here's one end of our volume control. We can see it moving. I don't know what channel this is, but let's see if this is the same thing on the other side. And it's not. Completely different. This is one side of the volume. That's what's happening. I'm going to take my hand off. I'm going to move the probe to the other channel, and that's what we get. This is what we should be seeing on both sides, but on the one side, we're seeing this. And again, here's what's coming in on that bad side. Oh, wait a minute. I must have not seen this. I could have sworn. Oh, interesting. What's going on here? Is just me moving this around causing this to change? So that's interesting. You can kind of hear that. Look at that. That all happens when I play with the balance knob. So it wasn't a dirty volume knob. It's been a dirty balance knob. So I think that makes things obvious for us. We need to clean the volume and balance pots. I almost didn't take this approach with the scope. I almost just said, let's just go right in and try cleaning the pots immediately before we waste our time. But I guess we've wasted our time, but at the end of the day, this is just more proof, more knowledge that we can all get by seeing this. So we know that there's some bad things happening between these two. So We're just gonna spray these real good. I'm almost out of CRC. Okay, with that being cleaner, let's take this stuff and let's go pretty crazy here. We need a lot. I'll just turn this back on. I'm going to see what I hear immediately. There's our relay. Volume down. Push in the speaker. Oh, that's not it. Oh, the speaker's already on. There's left. And there's right. So that sounds a lot better already. Let's go back to FM. There's left. But right is still quiet. So fortunately, that cleaned some things up for us. We see that coming into the volume knob. We have that, and we have that. And it's not really changing or acting weird from the balance knob. The balance knob seems to be okay. That's the one channel. And here's the other channel. Nice and smooth. So we've cleaned the balance knob. We've cleaned the volume knob. This is what's coming into the volume knob. Now I'm going to bring this up on our problematic channel. We see that. That's okay. And I'm going to leave that right there. Go to the channel that was working. Similar thing. Comes up just fine. But let's go back over to our relay output right here. What's coming off of our power amplifier. We see that on the one channel we have this. You know, it's being power amplified, right? Now let's go to the other channel, and we're seeing the same thing. Same weird waveform. So I had a feeling that this wasn't going to be controls, and that's why I took this route. The volume knob goes into the preamp, not the other way around. So the fact that we've got good signal at the volume knob, but bad signal at the relay means it could be the preamp or the power amp. So what we can do here is we can look at the schematic and we can see that C751 on both power amplifier boards is basically the first stop for the signal. So let's take a look at it on the right channel, and we see that it is bad. And then if we look at it on the left channel, we see that it is good. Let's take a look at the preamp. The preamp outputs are J406 and 405, I believe. So if we take a look at J405, that's bad. And we look at 406, that's good. The preamplifier inputs are J402 and 401. So let's take a look here. That looks good to me. And that looks good to me. So our problem is in the preamplifier. This should be simple to figure out, because all we gotta do is start poking around at all these components in here and see where that funky sine wave shows up. So if I take a look at the base of H408, we've got good signal. What about the base of H407? There's the bad signal. Let's go further back. Let's go to H406 and 405. Look at the base of H405. What about the collector? Alright, so there it is again. There's that bad signal at the collector of H405, collector of H406 on the good channel. Good. Okay, so we know, let's just keep going back here. Let's look at the emitter of H402 on the good one, emitter of H401 on the bad one, same. Now let's go to 403, 404. Emitter there, nothing. Collector, looks good. Collector on this one, looks good. So if we look at the schematic, it would appear that between the collector of H403 and the collector of H405, we have a problem arise. So that could be happening from our tone controls here. That's kind of where this goes. To get to those, we gotta take the faceplate off, so let's get to work. Someone's been here before, folks. There's a lot of scratches right there, and this is not tight. Thank goodness that worked. And she slides off. Somebody's taken the faceplate off before for whatever reason, but they never took any of this apart. And I can tell because Marantz put a little dab of glue on every fastener on these things. And these are all intact. This has not been apart before. So I get to be the first. What size socket is it? 12. Okay, so I can pull this out. Frick. Well, at least that was just a glue joint. Normally I break the paper right there. Let's just do the logical thing first. See if we eat our whatever and clean these out because they are dirty. We definitely heard that they're very dirty. Let's turn this back on. Let's see if doing any of that helped us at all. So if we recall, we were over here and we didn't have anything bad happening. But then we came over here and we did, and we still do. So what is causing that if it's not dirty controls? See, if this would be our treble, this would be our mid, and this would be our bass. And these all seem to be just fine. Alright, tell you what. I spent all day yesterday, maybe like 4 or 5 hours, just like troubleshooting, throwing components at it. Led to nowhere, so I'm just going to restart today. I'm going to take a whole new approach and show you some things I already know, but let's do this to make a more compelling video, huh? I think it's really weird that things are happening between the end of the first 2 transistors on the preamp board and the beginning of the last 2 transistors on the preamp board. What I'm going to do is I'm going to bypass this, and the way you do that is you look here, you got your yellow, orange, red, and brown wires. Your orange and brown are the output wires, and the yellow and red are the inputs. So I'm going to disconnect the output wires, and I'm going to link them right up to the input wires, effectively bypassing this entire assembly. If there is something going on in here, that'd be really bizarre, because this is a board of things that don't generally fail. You have ceramic capacitors, film capacitors, and resistors. It's exceptionally rare that anything like this ever fails. Let's get these wires disconnected. And we'll just take a jumper right here on the brown wire, which is the output of that board. Disconnect it right to the input terminal, this red wire. Then same thing with the orange wire. This is going to be output of this for the good channel. And then put that right there. So that's how we're bypassing everything. Let's go ahead and turn this back on. So we've got our tone coming through. Let's look at what's happening at the bad channel. Okay. Well, that's an improvement, right? Oh, but look at that clipping we have down below. Now that's different. What about the good channel? Huh. Now we have the exact same thing happening at each channel. Just for a sanity check, I want to put this back to the way it was with the jumper. So I'll move my brown wire jumper back to where it should be, and I'll move my orange wire jumper back to where it should be. except not take it off the orange wire. Okay, let's try this again. On the good side, I believe we had just a normal output out of there. And yeah, there it is. It's normal again. It doesn't look like we're getting any clipping, right? Yeah, there's all the way. That's max. And then on the bad side, oh, I don't like this at all. It's the same. Why is it working now? God, that's frustrating. Okay, I guess me swapping components and putting them back in fixed something. That's really frustrating. I don't know what to think of that. You know, I have been doing all of this on the dim bulb. I'm gonna take it off and just go right into the wall and do the same thing. Okay, plugged straight into the wall. What happens here? We are off the leash at our output for the preamp. Looks normal at max volume on both sides. I don't know what to think of that, folks. I don't know what I did. I tried replacing 2 transistors, H407 and 405. I replaced 2 capacitors, C410 and C414. I don't know what I did that made that work again. I just don't. Go ahead and switch to everyone's favorite song, and I'll play it through the speakers. Those channels are balanced and equal. So I guess next thing we should do is replace the power switch. Now if you somehow have one of these first gen Marantz receivers with an original power switch and it's still working, that's impressive. These are notorious for breaking on these first gen receivers. They are honestly not very good switches. And the way we're going to get this out is we're going to pull this piece right here. That screw doesn't want to come out, but it will eventually. And you get that by undoing the following screws. Tuner string is attached to this thing, so we'll want to be careful with that. Like I said, we got to be careful of that tuner string, so let's put some Scotch tape over this to kind of keep it on the pulley. And we can remove that from the bracket. And then here's the 2 other screws we need to take out. So there's our snubber capacitor sitting right there, and then we can see there's our switch with the wires. So we'll want to undo this. Here is the new switch that I happen to have. And when I go to stick this in, I quickly notice that the holes to mount this are not centered. So this hole and this hole will need to be drilled out. We'll go ahead and flip this over so our chips fall down instead of into the receiver. And we'll start with the 9/64 bit, move up to 5/32 if we find that to be necessary. And yeah, by enlarging both holes on both the chassis and the switch, we can get 2 screws to fit right in. Now I just got to get nuts behind them. And the reason I drilled it out is this is not threaded. I did a last time buy on these easy switches in like 2020 when they went out of production, but I was only able to get these ones without the threaded bracket here for the mounting. So this is what I'm stuck with, and I'm using one for the first time 5 years later actually. That's why it didn't matter that I drilled out the holes, is because they weren't tapped in the first place. And of course, because of that, I had to go buy some nuts. You'll never guess what I paid for these at the Home Depot. Let's just say it was more than $1 per nut. Alright, so for this power switch, we're going to take note of what's happening here. We've got our brown wire crossed across here, and then we've got our yellow and orange wires on the back side, and then we got our little snubber capacitor. So we'll just snip these, and then this is out. Strip the brown, strip the orange, and strip the yellow. And this here is a snubber capacitor that I pulled out of a scrap bin that was destined for the dumpster at my old job. I have a few of these. I don't really know too much about them, but it's 3 kilovolt. I think we're going to be just fine. Alright, so I've got my capacitor kind of laid in here like so, with the wires like so. So I can trim the excess. So this middle one here is going to be the brown wire. So I guess I'll go up and get that seated, or wrapped per se. I'll go ahead and get that soldered. If we look at our photos, we see that the yellow wire was with the snubber, the orange wire was not. And would you looky there, a brand new power switch. Now we just need to get this thing to go in the chassis somehow. And that's not going to be easy. Getting a nut behind this lower screw is almost impossible. In fact, I don't think it is possible given the space constraints with the original hardware. So luckily, when I went to the hardware store, I bought some 440 nuts and bolts instead of trying to work with those short M3 by 0.5s. So this one up here is easy. You know, I can get a screw in right there. It's through, I can get a nut on it, I can look, I'm looking right at it. But this lower one, it's tight. It's really tight. Oh my gosh. It threaded. Tell you what, getting this nut to thread has been one of the worst experiences of my life. This is hell. Just terrible. It's a good thing you can't buy those switches anymore, so none of you will have to worry about suffering like this. I haven't even tightened it. Alright, let's go ahead and test this power switch on the dim bulb and just make sure we're not too far off. Turn the dim bulb on, and when I hit this button, the receiver turns on. Here's what I was talking about with that nut. Like, it is under there, right there, and that was just nearly impossible to get to. How about we get this bracket back on and throw this thing back together? And of course, we're going to need one of these. Very nice. Now what are we going to do about this filthy, awful faceplate here? Unfortunately, I was looking closely and it looks like this has been used a lot and the tape and aux screen print are heavily damaged. So we don't have to be too careful, luckily, because the damage has been done. We're going to start out with just some dish soap and warm water. And a cloth, so I'll get it wet first. See what happens here. So it does appear that some of this yellow is coming off as I scrub quite hard with the dish soap, which is not ideal. I'm wondering if the semi-chrome polish will do better. This triggered so many of you last time, I'll just do it again. Use my wife's nice towels that are stained because they're not new. Calm down, people. And a concerned viewer pointed out last time I was using the semi-chrome polish that it needs to be used with skin protection. And there's a little sticker over here covering the barcode, but it extended over to there. And this is the part that says avoid contact with skin. So, silly me for not being proactive in removing the rest of that label until now. But yeah, it kind of goes without saying. Semi-chrome polish is some pretty nasty stuff. It's not legal for sale in California. I'm going to turn on the bathroom fan, and that still might not quite be adequate ventilation. Yeah, just be careful. So we'll start with that and see what it does. Well, that's a lot better, don't you think? Looking pretty clean there. I'm pretty happy with that. Now we just gotta do the same thing to all these absolutely disgusting knobs and buttons. And remind me, which ones of these lamps were burnt out? It was the stereo indicator, that one, and that one. Let's get those replaced real quick. The tuner meter lamps are pretty simple. You just got a screw right here and a screw right here. You just kind of push this out like so. And it was this one right here that was bad. Just take our tweezers, pull that out, and what do you know? I've got two original F8V Marantz fuse lamps. So put that first one back. Put that away. Let's not snag our wires. Use a smaller screwdriver so that it doesn't want to snag the termination so bad. So a lot of little things like that on these where it's like the mechanical fit just isn't quite there, but you can work around it. Now a fuse lamp on the first gen, I don't know if we can get it without removing the vellum paper, but if I had to try, I would do it like so. There's one screw right here, and another screw right here, kind of buried. Does that open this up? Yeah, it does actually. So that's what's kind of holding us back here. I'll just say it again. This is not the proper way to do this. The proper way is to take off the dial face printed thingy and the vellum paper. But I'm just curious. I'm just curious for my own sake. Like, is it possible to even do this? And can I slide it off? Yes, I can. Look at there. Slid it right off. Does it give us the ability to kind of roll it a little bit? Yeah, it does. It's cool. So I just got this lamp out. Let's get the new one. We'll try to carefully install the new one with our new level of access here. And there you go. This can go back together. And of course, we can't forget this guy. Slide it back on. Come on. Dab of solder. And that's all set. The next thing I'm wondering is, can we replace the stereo lamps? Or lamp? I don't know how many there are on the 2245, but I know on the 2230 and 2270 there's two for the stereo lamp. And I think they're in series, so maybe just one of them's burnt out. And we get that by taking out 3 screws. This one's most difficult to get to because of the tuner cap pulley. Now I'm thinking, maybe we should have just left that resistor not soldered in place. Oh well. To undo this little bendy guy right here, holding all the wires in place. And then here's this board. And there's our 2 stereo lamps. Real quick, I'm gonna check each lamp for resistance to see if one of them is bad. So 1.1K, that's not very promising. And then over here, 18 ohms, that's far more promising. Then my brand new bulb right here, just measure it on the meter, I guess. I'm getting like 18 ohms out of that too. There we go. So I'm willing to bet if we just replace this one right here, we'll have a working stereo lamp. Part of this is also cringe entertainment for you all, so you can see whether I successfully desolder all these things with the tuner string right there. I'll have to loop that wire this way to get the other end of the lamp. And there we go. The lamp should come out with just a touch more convincing with the soldering iron probably. Let's see. Oh, it's also glued in place. That's really obnoxious. Okay, I think we're just held on by glue at this point. Yep. Let's stick our new guy in. Bend the leads to make it stay. Solder it in place. Make sure it's straight. Get this one. And there we are. We'll roll this back into place. Now let's get our screws back in. Alright, let's see what happens now. Look at that stereo indicator. That one doesn't work, and now that one's burnt out too. That's hilarious. See, this is what happens when you use used fuse lamps. You shouldn't do it. And then since these are all old, they're all willing to just go at any time. Proud of the stereo indicator though, that's pretty cool. Okay, forgive me. I went back and I replaced all the lamps with new ones. I'm trying to keep the scope of this video just to be repair. Like, we're just fixing what's absolutely necessary. So the next thing I want to do is clean this thing. And I'm very sorry to all of you, but I don't think I'm going to take this one to the power washer because it is, you know, pretty clean. And it's really not going to benefit that much from going there. Oh, come on, you think I'm actually not going to power wash it? Let's go. Power washing nighttime edition. Open 24 hours. Here we go. I even brought a camera operator this time. I thought this was a video. It is. This one wasn't too bad. I think that's enough. I don't think I'll bother with getting the bottom because it was pretty clean like you all saw. Let's get this home. Hey, are you using the oven later?
Why do you ask?
No reason. Any other fun jokes you want to make? All right, we'll get her with the compressed air. I mean, come on, folks. You are not going to believe this when you see it. It looks really nice. So of course we can't help some things like the inevitable corrosion and whatnot that's going to show up on stuff like that. You know, down there a little bits, but like, look at that transformer. Look at those filter capacitors. Look at those circuit boards. Like, squeaky clean. Power supply board looks great. FM tuner, I mean, come on. It is really clean in here now. The only casualty I found is the glue joint right here, where we're holding the dial face to the chassis here. But that's a pretty easy fix. So the ultimate question now is it going to turn on? You know, I've had a 100% success rate doing this crap, but I'll tell you what, I still get nervous every time for this part. So let's go ahead and turn this on and we'll push the magic button. No shorts. Relay click. Yeah, now we gotta see if we get sound. I've got the mains turned off, but the remote's turned on, so let's check our DC offset at the remotes. 25 millivolts, great. And 33 millivolts, great. Nothing wrong there. So we'll switch it to FM, turn the volume down, hit the main speakers button, and no sound. Because one of these is the tape monitor and it's turned on. Told ya. And that is even sound out of both channels. Powerwash and oven bake number 5 is a success. So now it's time to get this thing off the dim bulb, into the wall, set the amplifier adjustments like the bias and DC offset, and see how much power it's making. But before I do any of that, I need to measure across pins J803 and J802 and set the power supply. Yeah, J802 is just this one right here with the red wire coming off of it. Pretty easy to get there. And then J803 is just ground. So why don't I just connect it to ground? Why do I have to connect right to J803? Well, that's what the service manual says, so that's what we'll do. We'll put these on our probes, and then we'll be able to make this measurement. And I'll have one camera, potentiometer we're supposed to turn, and if I turn it, we can bring this right into 35 volts. Just like that. And for DC offset, we just measure at a speaker terminal with the speaker turned on, of course. And this looks perfect to me. I just turned the receiver back on a little bit ago and it seems to be stabilizing. I believe it is this one right here, the outside potentiometer that you would turn. I'm not going to touch it because that's a great number. Let's check the other side, see what's going on there. I don't need to move that one over because it's the same. Here, I'll prove it to you. The ground is ground. That one's a little bit higher. I wouldn't mind giving that one an adjustment. And of course, it's on the right channel, which requires us to go from underneath. The boards are the same, but they did a like 180. So like all this stuff up top here is on the bottom over there. So it's kind of annoying. Let's just turn this. We're still at 40 and it's gonna be this one right here. A lot of people replace these quite often. That's probably what I should do, but I mean, I'm able to get this into spec. And there you go. Now we're closer to 0. I like that. And then for setting the bias, this is a later gen 2245, so we set it to 10 millivolts. Service manual says measure across J754 and J760, but those are hard to get to. And you know it's way easier to get to? The things that those J's are measuring. The voltage drop across the collectors of the output transistor. So I've just cut my probes on the screws, the mounting screws for these output transistors. And we see we're a little high. I'm going to bring this to 10. And that works great. Gotta do the same thing on the underside, so we gotta flip it over like we did earlier. So I'll put my probes right in there. See, we're at 31. I'll take this, bring it down to 10. So there you go. I think this amplifier is ready for some power testing. All right, folks, this is the moment of truth. We've got 1 kilohertz going through the amp and our 8 ohm load resistors. This is the right channel. Let's see what kind of voltage and clipping action we get. There it is. Break it down. It looks like about 21.7 volts AC. That, folks, is about 59 watts per channel. That's a great number. Let's go to our left channel. Move things over here. Bring it up. There's our clipping. And it's about done right there. 21.5, similar enough. Especially for something unrestored. Keep that in mind, folks. This is completely unrestored. It's just repaired. All right, let's put it back together. And there's a few special treats I gotta show you in the back. I told you I had one last special thing, and that is this. I took the old broken AM antenna mount, modeled it, and 3D printed it. So I'm actually test fitting for this for the first time. Let's see if this fits. Okay, this is just my first attempt with no confirming measurements or anything, and it would appear I've done it. Yay. And they even took the time to model the little hexagon cutouts that are in this original mold here, so the nuts just fit right inside like stock. And I can just tighten that. Not gonna over tighten, enough to hold it. And then back here, we have a nut and a washer on both ends. Maybe I should have just designed this part the same way as I did the other part and put this feature in here, but I did not. I didn't expect to use tweezers so much with M3 fasteners on this project. There you go. Good as new. You'd never know it. Might even be strong enough to use as a handle. Yeah, feeling ridiculous. Yeah, look at that. They say not to use it as a handle. Look at me. This will go in the trash. There it is, folks. Let's hit it. That sounds really nice. So there it is, folks. Yet another one fixed. I like this thing. Would I run it every day right now, though? No. There is a lot that needs to be done to this thing, as you've noticed. I've tried to keep this video as, this is how you repair it. This is how we troubleshoot. This is how we figure out what's wrong. And now, this thing is a good candidate for a restoration, because now we know it's working. We know what was wrong. The one capacitor I tested in here that wasn't a filter capacitor had 24 ohms ESR when that's only supposed to be around 3 for a capacitor like that. The filter capacitors, they're 9,000 microfarad. I believe when we tested them they were only about 8,000. So those will need to be replaced. There's a lot of hours on this thing, and I wouldn't really want to play this too much more as it is. However, if you were to sell this on eBay right now in this condition, you'd probably make over $1,000. So if you enjoyed this video and you'd like to see this thing fully get brought back with all new lamps, new vellum paper, new capacitors, new transistors, all around, all the things you should do to these things when you're restoring them, consider subscribing, because I'll get to that eventually. So with that, thank you so much for watching. Thank you to my subscribers, and thank you to my members who get early access to videos, just like this one. I will see you in the next one. But before we go, I want to break out the reason these videos exist. And in particularly the reason why I like these so much. This, folks, is my dad's Marantz 2270. This is the first time I've powered it on in probably a year. I just wanted to get it out here and show the difference in what proper good lamps and what used up vellum paper looks like in terms of brightness and color. So that's why this looks so dim and crappy. This receiver is the most important piece in my collection, and it's the most important piece I will ever have in my collection. Not just because it's my dad's, but because this was my gateway into the vintage world. Many of you have asked me this over the years, and there are a lot of new subscribers as of recently on the channel. They ask me, how did you get into vintage audio? It's this one right here. The story goes I was a middle schooler. I was, what, 11 years old? And my parents had upgraded from their Klipsch KG4s, which you've seen in plenty of videos, to, I just had to look it up, a Bose Acoustimass system with the cube speakers that were kind of on an axis and you could turn them and you put one in each corner of your room and you had a subwoofer. They ran those with their late 80s Yamaha receiver that they bought with the KG4s. So the KG4s were just sitting in the basement, and one day I was like, I want these in my room. So we bought me a used Yamaha receiver on eBay, and I was off to the races. But then as I'm getting more into stereos and asking more questions, Dad comes home with this thing right here. It had been sitting in his office at work for years, untouched, unused, probably since the 1980s. And he gives it to me and says, you know, it didn't work last time, all the lamps were burnt out, it wasn't working right. And sure enough, I plugged this thing in, none of the fuse lamps work. The indicators work, but none of the fuse lamps work. It'd make this awful buzzing sound before the relay would click in. But once that relay was clicked in, I listened to what was coming out of this thing and compared it to what was coming out of that used 90s Yamaha receiver I had. Like, you know, just taking the speakers and swapping it between the receivers, swapping the input with it, and just listening to the difference. And what I heard just blew my mind. How was it that something so old and so broken could sound so many leagues ahead of something so much newer, so much more modern? And for that reason, the hype is real, folks. I mean, I think the prices are insane, but the hype is real. There is something about these. There is something about their sound. So I'm playing with this more and more, and eventually it just completely doesn't work anymore. And I try to fix it in all my stupid glory of not knowing the first thing about vehicles IR. And it's so broken, it won't turn on anymore. And we take it to a stereo repair shop in like, what, 2007, 2006? And they looked at it and said, it's not worth repairing. We're not going to fix it. It's going to be too much money. So I held on to that thought and had a goal in the back of my mind. One day, I'm going to learn how to fix this. So after that, I went to garage sales, found stuff, you know, figured out, you know, how to do garage sales when you could actually find stuff like this in the late 2000s. Can't really do that anymore. And that stuff held me over until late college. I had just gotten into some Pioneer stuff that I bought used that needed to be fixed. It was time for me to take this thing on. And I'm going on Audio Karma, I'm asking the questions, and through there I meet my good friend who has taught me a lot of what I know. What I'm saying is we all owe it to this receiver right here for giving us all of this. There's a real chance that this doesn't exist without this receiver, and my dad saving up his money in high school to purchase this at $600, which is no slouch back in the early 70s. Dad is alive, he's watching this video. Hi Dad, love you. And he noticed, and some of you may have noticed, I was wearing this Levi's jean jacket in the beginning of this video. And that's because it's my understanding that Dad wore that jacket around the time he was listening to this thing in the 70s. So that's what this thing reminded me of, and that's why I was wearing that jacket. I should wear that jacket more often. It's pretty cool. So that's it. That's the story. Happy holidays, Merry Christmas, happy whatever you celebrate. I will see you in 2026. Take care.